Hi Year 5, welcome to your very own math skills lesson. Thank you very much for joining me and I hope you are ready to get started. Okay, so to support you with your explanations in this math skills lesson, I need you to be using some of this key vocabulary that I've got written on my board. So let's go through that vocabulary now. We've got partition, well done, part, whole, thousands, hundreds, tens, ones. Good work. Fraction, decimal, percentage, equivalence, multiple, inverse, half, double. Great. We might actually talk about tenths and hundredths too. So continuing that place value. So using this key vocabulary to support your explanations to show the person next to you that you know what you're talking about and you really understand this maths that we are going to be practicing today. Okay, you ready? Let's get going. So how it's going to work in this session is I'm going to work out this side with your help, so please help me complete this side, and then I'm going to reveal the next side for you to complete on your own. Okay, so as we can see, we have got an incomplete part-whole model. However, I've got all the parts to help me get to this whole, and sometimes we are being asked to partition that part into even smaller parts or figure out what that missing part might be. Okay, so looking at this number, we've got 3,637, 3,637, and we can see that we've partitioned 3,000 into 1,500. Some of you be quick, snap, realise, yes, that is a half fact. Fantastic. So that means we need 1,500 in the other bubble as well. When we've got 600, we've partitioned it into two parts. However, we already know that the tens and the ones must be 0, 0. So they've been partitioned into hundreds. So you could have 1 and 5, 2 and 4, 3 and 3. I'm going to actually go for 3 and 3 because I'm a big fan of using double and half facts to really help me with my mathematics. 30 doesn't need partitioning, and 7, there are many different ways we can partition 7. I'm going to go for 2 and 5. You might choose something else when partitioning 7. Tell your top partner a different partition you might do for 7. Right, now it's your turn. I want you to have a little look at this incomplete part-whole model. You have the parts like I did, find out the whole and then partition off into smaller parts. Off you go. Pause the video to give yourself enough time. Right, back in. So we've got 6,254, 6,254, that should be nice and quick. Then our 6,000 can be partitioned off into 3,000, so the other remaining partition will be 3,000 as well. Yes, we have half that. Then we've got 200, we know we've got 150 of that, meaning that we have 50 remaining. So well done for those who have managed to spot that. We've got 50 and 4 has been partitioned into 2 and, yep, you're right, that's 2. Great work. Now you're helping me out again. So we've got 7,789, 7,789, thank you for helping me. Our partition of 700 has got 50 and 50. We can see 50 and say 50. So 50 and 50 is what? That's 100. We take that off the 700, means we're left with 600, and now I can play about. How am I going to partition 600? I might go 2 and 4. So 250 and 450 to get me to my 700. 7,000, you can partition that however you like. That can be 3,500 if you're going to half it. Some of you might simply do a 4,000 and a 3,000. Again, there are many options for that, so check with your adult that you can do that correctly. And then finally, our partition of 9. How many different ways do you know to partition 9? Off you go, write them down whilst I'm choosing 4 and 5. How many different ways did you get? Nice to hear. 8 and 1, 3 and 6. Good. 7 and 2. We've got a few there. Oh, We ready? This one's for you. Look at the parts that we know, partition off into smaller parts, but ultimately try and find that hole. Off you go. Pause the video to give yourself more time. Lovely, so we can see we've got, oh yes, that's 10,000. Well done for spotting the extra number in there. So we've got 10,568. So we've got 10,568. Great. So for 10,000, we've already got 3,000. Number bonds to 10, 3 and, yes, 7. So we've got 3 and 7,500. We've already got 150. So how much is left to get us to the rest of that 500? Add the 50 on, gets us to 200. We need another 350. Right, 60 is fine there. And there are many ways we can partition 8, as you know. Write them down, all of them. I want to see them all. And I'm going to go for 1, 7. Great. And hopefully you've got a list of different bonds that make that number 8. Great, my turn again. You're helping me out. What do I know? I know the wholes. How do I read that number? 9,045, yeah. I've got 2,000. Oh, I think I could figure out this part. 3,500, 3,500. We know that's, yes, that's 7,000. So actually I've got 7,000 and 2,000. I've got the 9,000. 20 and 5 is 25. How much is remaining from that 45? Yes, 20. So this must be 20. And finally, we can partition 2,000. Give me 3 different ways you could partition 2,000. There are so many different ways you could do it. Off you go. I'm going to go for 1,999 and 1. There are my ways of partitioning 2,000. Off you go. You've got this example, you've got the whole, you've got some of the parts, and you've got some of the smaller parts. Complete the missing bubbles. Off you go. Great, we're back in. So we've got 6,020, 6,070 we've got. So we've actually got 6,070 in these bubbles so far. Then we've got 28. So we've got 6,098. So we know that's 28. So we've got 6,098. Yeah, we happy with that? So from 6,098, what is missing to get us to 6,148? Either 2 is going to get us to 6,100. 2 and 48 together, yeah, there's another 50 missing. So fantastic if you managed to spot that. So maybe you might have spotted the 20 and the 28 together to get you the 48, and know you need the 50 and the 50 to get you to the 100. So well done if you spotted that connection. From 50 to 35, there's a difference of, yes, there's 15 as a difference. And then finally 6,020. Can you give me 3 different ways you could partition 6,020? Off you go. I'm going to go for what you can hear. You can hear 6,020. So I'm going to partition them off into the very simple forms. Well done. Again, you're helping me out. So what do I know so far? 5,555, yeah. No, 2,500. Oh, actually, they're giving me some information. 25 and 25. Yeah, with 50. Nice double fact there. 505. Right. So I've got 505 and the 50. So I've got the 555. I just haven't got the 5,000. I've got 2.5 of that. So yes, exactly. You've spotted another double fact. 2,500 was missing there. Now we need to partition 2,500. 3 different ways you can partition 2,500. Off you go. I've gone 2,200 and 300. There are many, many ways we can partition 2,500. Your turn now. You've got an incomplete part whole model. You know the whole, you know some of the parts. This one's quite open, so figure it out. Off you go. Great, let's see what we know. 5 and 1 gives us 6. So we're missing 1, aren't we? We haven't got that 7 yet. We've got 30, which is being made up of 17 and what? What's missing? 17, what's the difference between 30 and 17? Yes, we've got a difference of 13 there. So we've got 36 so far. So 36 so far. So we haven't got 7,000 anywhere, have we? So let's put 7,000 down. Looks like there could be more than one option. So now we've got 7,036. How are we going to get from 7,036 to 7,067? So we're missing 1 to get the 7, and then we're missing 30. So we're missing 31. So well done if you managed to spot that one. Now we're going to partition 7,000. Can you give me 3 different ways? Let's go. Number bonds to 7. I'm going to go 5,000 and 2,000. That seems to be my favourite number bond to 7. I keep going back to that one. Great. So now you have got some incomplete part whole models that I would like you to practice completing yourself. Off you go. Pause the video to give yourself more time. Right, so we've got 5,000. 5,000, we've got the 405 and 405. That gives us 810. 810 add the 40 gives us 850. So we've got 5,850. So well done if you managed to get that. Hopefully we've spotted this bond here, 750 and 750 gives us 1,500. 1,500 on at the 8,000 gives us 9,500. 9,513. Great work. Right, let's look at the 2 parts we have. We've got 5,001 and we've got 3,300. So together they are 8,301. Yes, we happy with that? So now we've got 8,301. We need to try and get to 8,802.4. So what are we missing? We're missing some hundreds. Yes, how many hundreds are we missing? We're missing 500. We're missing 1, and we're also missing a tenth. So we could put, how many tenths? 4 tenths. Yeah, we're missing 4 tenths. So we could put the 4 tenths on either the 500 or the 1. It doesn't matter each or you could have partitioned that 500 into smaller parts, meaning things are a little bit different. Great, we'll move to this one, very open-ended one. So we've got 6,712, however we've got 350 already given to us. So we know 700, how do we make 700? Yeah, we need another 350 to make 700. Yeah, we'll put the 12 in this one, and then we'll put the 6,000 in this one. Let's think efficiently, don't overcomplicate it. 1,799, hopefully we've 99. You again may have partitioned that into many different ways, so get your adult to check. Right, let's have a little look at this one. 4,500 doubled gives us, yes, it gives us 9,000. Double 4,000 gives us 8,000. Double 500 gives us another 1,000. We add that on, 9,000. Then we've got 0.5 and 0.5 gives us that whole 1. So 9,001. Well done. Don't forget you can put your place value hats on if that helps you when writing those numbers out. Second activity for today, second of 3. We are going to be working with some variation facts. We've done this activity before where I give you a fact that is true. 5 times 12 equals 60. We know that's true. Double check just to give you some confidence. Right now, you should hopefully know some of these facts, if not all of them, from this fact here. When you're thinking about relationships, use what we know to help us figure out what we're not as quick at knowing. Okay, so 12 times 5 is, yes, 60. 120 times 50, what's happened? This has increased by 10 times, this has increased by 10 times. 10 times 10 times is 100 times, meaning that this will increase by 100 times, giving us the value of 6,000. So we've got 500 times 12. What's the difference? 100 times is the difference, meaning that our value still changes by that 100 times as well. So it's not 5, what we see, it's what the 5, we can see the 60 is actually changed to a 12. Okay, so this is used a half fact. So 5 times 6 is going to be half of what 5 times 12 is, so that's 30. However, yes, it has been increased by 10 times and 10 times, so it's been increased by 100 times, making that 3,000. Okay, I'm going to leave you with these ones. Use these facts and obviously our main completed fact to support you in completing the rest of the facts. Off you go. Great, so let's look back at what we know. So we've got 2.5 times 12. So the 12's the same. The 2.5 and the 5, what's their relationship? It's half that value. Fantastic. So the 60 needs to be half of that, which is 30. Fantastic. Now we've got the inverse. We've got 60 divided by 5 equals 12. But actually we've got 600 divided by 50. What are we going to be left with? 600 has increased by 10 times, but it's been divided by something that's been increased by 10 times, so we should still be remaining with our 12. Then we've got 60 divided by 0.5. So what's happened? We've actually divided by something that the power value is 10 times less. So we're no longer just 12, we need to go 10 times more, because this value here is 10 times less, meaning our quotient is 10 times more. Lovely, and then we've got 0.5 times by 12. So that's a half 12 times. So a half 12 times is actually going to be 6, as we can see our relationship links there. So fantastic work if you manage to solve those. Now we have a different variation fact for you. I would like you to use the red fact to figure out the other facts that are missing. Off you go. Great, we're back in. Let's see what we know. So 84 divided by 7 will give us, yes, 12. Look at the calculation, think of the inverse. So now I've got 70 times something equals 840. what do we notice? Actually, the 7 has increased by 10, and this value is still only increased by 10. So meaning that this part has remained the same. Here we've got an increase by 10 and an increase by 10. 10 times 10 times is 100 times. So we've got 8,400. Great work. What have we got here? We've actually got a decrease by 10 times. So what's going to happen here? A decrease with 10 times. So we've got 8.4 there. So fantastic, you managed to spot that relationship. 7 times 24, what's happened? We've got 7 times 12. We've doubled the 12, meaning we've doubled in the 84. Double 80, 160. Double the 4 is 8, 168. 168. Right, we've got a value which is 100 times more. However, we've divided by a value that's also 100 times more, meaning that the other part of the calculation will remain the same. Okay, what's happened here? We've got 7 times something, which is 8.4, which is 10 times less. So meaning that our 12 has been divided by 10, meaning that 7 times 1.2 will give us 8.4. Now finally, we've decreased this value by 100 times, and this by 10 times. 10 times 100 is 1,000 times. So actually, if we've got our 84, 1,000 times less, we've got 1, 2, 3. We've got another 0. So it's actually 0.084 because it's by 1,000 times less. So well done if you managed to get those results there. Giving you the variation fact now without any other calculations that I'm telling you you should know. You now need to tell me what you do know as a result of that completed fact. 15 times 3 equals 45. Off you go. There are lots of different facts you could know. You play around with the numbers initially. So 3 times 15, we can let go of the order, 45. We know the division statements as a result of that. Then we can play with the power of that number. So we go 150 times by 3. Yes, you're going to give it 10 times more. So whatever happens in the multiplication, what times that by 10 is going to have an impact on our other side of our calculation. Thinking about the division, so if we had 450 divided by 3, because that's 10 times more, but that hasn't changed, meaning this will be 10 times more as well. So it's 153 times. There are lots of different calculations you could have had, thinking about double facts, thinking about half facts, thinking about increasing by 10, 100, 1000. They are different facts that you know because you know that fact. So get used to using other facts to help you figure them out. Part 3 of our lesson, we are going to be looking at fractions, decimals and percentages. Okay, so I want you to look at this representation here. There are 100 squares in that grid. I'm going to give you that because it might not be so clear on your screen. I would like you to write the fraction that represents that grid there. Off you go. Great. So we know there are 100 parts, 100 equal parts, and 50 of them are shaded green. 10, 20, 30, 40, 50. So 50 parts of 100 is equivalent to 50 hundredths. Yeah? Fantastic. Now, looking at that representation, I would like you to write the fraction that represents that representation. Off you go. So yes, now the representation does look very similar. However, we can see that there are 10 equal parts altogether, no longer 100, and 5 of those are shaded in. So 5 parts of 10 is equivalent to 5/10. Brilliant. Can we see the relationship between those representations? Finally, got a representation. Can you write the fraction that represents that representation? Off you go. Great. So, God's been shared into 2 equal parts, and one of those is shaded green. So we know that 1 part of 2 is equivalent to 1/2. So we can see the equivalence between these fractions, 50 hundredths, 5/10, 1/2, are equivalent to one another. So that equals that, that equals that. However, this is the most simplified form of that fraction. So well done if you managed to support me in completing that task there. Look carefully at those fractions. Now, I would like you to write a fraction representing this image here. There are 100 squares again, off you go. So we know the shape's been shared into 100 equal parts and 80 of them have been shaded green. Let's just double check. 10, 20, 30, 40, 50, 60, 70, 80. Great. Now we've got a different representation. How are we going to write that? Off you go. Brilliant. So this shape has been shared into 10 equal parts and 8 of them have been shaded. But can we see the representations? They are exactly the same. So we know that 80 over 100 is the same as 8/10. So 80 hundredths is the same as 8/10. Fantastic. And finally, can you write the fraction that matches that representation? Great. So it's been shared into 5 equal parts and 4 of them have been shaded. Fantastic. So now when we look at these representations, we know that 80 hundredths, 8/10 and 4/5 are all equal to one another. And great. To help us simplify, we look for a common factor. Great. So we can see in here, 10 goes into both parts. How many times does it go into? 8 times and 10 times. Now we're looking for a common factor this time. Yeah, 2 was that common factor. How many times does 2 go into 5? 10, sorry, it will go 5 times. How many times does 2 go into 4? Goes in 4 times. And we were able to simplify that fraction. So this is the smallest form because there's no other ways we can do simplification, because our 5 is a prime number and we've got the even number of 4 there. Right, so looking at this fraction now, I want you to write as many ways that you can write this fraction. So thinking about simplifying it into different ways. Off you go. Great, so what can we see? We can see the shape being shared into 130 of them being shaded in. We know that's equal to, yes, 10. 3/10. Can it be simplified any further? Why? Say why. Explain why. Yes, we had a common multiple that 10 could go into both of those. However, common multiple is only 1. We can't go any further because 3 and 10 don't have any common multiples. Great work. So we're going to move on to some decimals now. Looking at this, we can see our representation has been partitioned into 10 equal parts. We've got no holes coloured in. There's no holes of those shapes coloured in. So 0 holes. How many tenths have we got coloured in? There's 10 equal parts. We can see 3 tenths coloured in. Fantastic. The 10 equal parts, 3 of those are coloured in. Can you have a go at writing this representation as a decimal? Off you go. Right, so what have we got? Can we see any holes? No, so there's 0 ones. How many tenths can we see? There are 8 of those tenths coloured in. So we've got 0.8. Fantastic, that's how our decimal works. Great work, and finally we're moving over. Can you have a go at writing that one? Off you go. Great, nice and easy. We have got 0 holes, but how many of those tenths have been coloured in? 1, 2, 3, 4, 5. So we've got 5 tenths, because this is our tenths column. Great, you might have recognised these representations when we were talking about fractions earlier. So looking at this representation here, we've got 8 parts of 10 is equivalent to 0.8. 8 parts of 10 is equivalent to 0.8, or 8 tenths it's called. Lovely. So now we've got a different representation here. We're going to work together initially. As you can see, they've been split up into hundredths. How many hundredths can we see coloured in? 0 holes. But how many hundredths? 10, 20, 30 hundredths. So 30 hundredths, I can't fit 30 in the hundredths column, so 30 hundredths is actually equivalent to 3 tenths. So 30 hundredths is the same as 3 tenths, as you can see, if we thought of those as tenths lines as before. Can you write this fraction here, this representation here, into its tenths and hundredths and its ones? Off you go. Great, how many hundredths can we see out of the 100 squares that we provided? Yes, 55 of those have been coloured in. There's no whole ones, no completely shaded grids, but there are 55 hundredths. 55 hundredths is the same as 5 tenths, 3, 4, 5 tenths and 5 hundredths. 5 tenths, 5 hundredths, 55 hundredths, they are the same. Off we go. Can you finish that decimal off there? Well done. Great, what can we see? Can we see any whole ones? No, we can't. How many tenths have we got? We've got 10, 20, 30, 40, 50. 8 tenths and 1, 2, 3 hundredths. Or we can have 83 hundredths. 83 hundredths or 8 tenths and 3 hundredths. Just the same as saying as 8 tenths and 3 ones, 83. Okay, no difference, just the unit is smaller that we're working with. So again, decimals. That's a duplication. We're moving over now to fractions, decimals and percentages. I would like you bear in mind this grid is made up of 100, to show this as a fraction, a decimal, and a percentage. So this grid has a representation of 100 squares. Some of it has been shaded in. I would like you to show me as a fraction out of 100, a decimal, and also a percentage. Remember, a percentage is out of 100 also. Off you go. Right, we're back in. So how many squares can we see coloured in out of the 100? Yes, so we've got 30 100ths. Then our decimal, how do we write our decimal? Remember our ones, tens, hundreds. Got 0 whole ones, but we've got 30 hundredths, which is the same as 3 tenths. So it can be just 0.3. And finally, percentage, how do we write percentage? If it's 30 of the 100, it's very, very simple. It's 30%. Well done if you managed to get that. Now, we've got a different representation. Please look at this representation, write it as a fraction out of 100, a decimal, and also a percentage. Off you go. Great, so how many of the 100 squares can we see coloured in? We can see 83 hundredths. It's written as a fraction. Our decimal, remember, ones, tenths, hundredths. No whole ones. How many tenths have we got? 8 and 3 hundredths. Or we've got 83 hundredths. However you see it. Do you see the tenths and the hundredths, or do you just see them as hundredths and realise that value of that completed 10? And finally, percentage wise, we know that that's 83%. So fantastic if you manage to solve that one. Looking at this one, we have got a representation of our 100 square. Please write it as a fraction out of 100, a decimal, and also a percentage. Off you go. Great work. So how many of the green ones can we see coloured in? 55 hundredths as a decimal. Thinking about place value. Ones, tenths, hundredths. We've got no whole completed ones. We've got 5 tenths and we've got 5 hundredths, or we've got 55 hundredths, and we can see the value of that tenth. The percentage would then be 55%. So fantastic if you manage to get that one. To finish us off, we have a grid of fractions, decimals, and percentages. At times you've been given the fraction and need to figure out the decimal and percentage. At times you're given the percentage and need to figure out the decimal and the fraction. And other times you've been given the decimal and need to find out the fraction and the percentage. For this time being, you just need to write the fraction out of 100. If you think you can simplify it at the end as a challenge, that's a challenge for you. Off you go. Pause the video if you need more time. The decimal we get with 22 out of 100 is 0.22, and the percentage would be 22%. 5 hundredths, got 5 hundredths, there's no tenths, 5 hundredths, we've written as 5%. 33% is going to be the same as 0.33, which is the same as 33 over 100. Then we've got 0.65, let's go percentage first, is the same as 65%, and then we've got 65 over 100. Then we've got 0.02, which is 2%, and it is 2 over 100. So fractions, decimals, and percentages are all representations of parts of that whole. So whatever your whole quantity is, whatever your whole shape is, the part of that can be represented as a fraction, it can be represented as a decimal, and it can also be represented as a percentage, meaning that they are the same. Okay, at times your fractions can be simplified into even smaller forms. That's it for today, so thank you very much, Year 5, for joining. I hope you're staying safe and I hope you're keeping well. Bye.